Okay, so this is the last session for today in this track. And as normal, I will look for questions in the chat if you have any questions during the process, or if you are wanting to speak. At the end, I will allow everyone to unmute themselves. You will be on mute for the duration of the session. You'll be able to unmute at the end and ask any questions directly. I will now hand it over to Greg and Joe. I've got for a moment to introduce themselves and the session and to go from there.
Awesome.
Over to you.
Thank you so much, Anna. Thank you. And good day, and thank you everyone for joining us on today's topic, IBM Mainframe DevOps. My name is Joseph Cruz. I work for Converge Technology Solutions. Just a quick intro. I describe myself, I'm not a fan of titles, but I do describe myself as an IT broad spectrum professional or technologist. 30 plus years on mainframe, and also a lot of experience on distributed platforms, a lot of different operating systems and products and things like that. Also application development, a lot of experience there. A lot of experience hybrid cloud, Linux on Z, and other distributed systems, and I'm really happy to be here. I'll hand it over to my colleague, Greg, to do his intro.
Oh, here.
You're on mute. There you go.
Find my mute button. My name is Gregory Powiedziuk. I work with Joe, same company. I describe myself as a system engineer, sometimes system architect, but also a DevOps engineer. And that's why I'm here.
Well, Greg, thank you. And what I want to say is Greg is an unsung hero with that introduction. He's one of our senior engineers. He is very multi-talented and diversified, and I think you're going to learn a lot and gain some critical insights when he goes into the DevOps pipeline. So with that, Greg, we can move on to the next slide. And okay, so we've already, perfect. All right, so our agenda, and this is a two-person presentation. I'm going to spend just a few minutes framing things out, and then Greg is going to walk you through, a lower level discussion in terms of, the roadmap, the journey, and considerations, and some of the things that have been done. Right, so we'll talk about what is DevOps and why. Right, the components that make up a CI/CD pipeline. We'll talk about your current. Most enterprises, their legacy SCMs versus a new DevOps, model. We'll talk about other things regarding the CI/CD stages, the pipeline. We'll talk about how to develop, a shared, more reusable, robust. I like Greg usually calls it universal pipeline, using parameters and variables. Right, and then we'll talk about how to run the pipeline manually and how to do a build and deploy and things like that. And then I'll wrap it up in terms of benefits planning and some considerations and issues and how to contact us. So that's what we're going to cover, and we're going to do it quickly because we're limited on time. So the first question, right, is why enterprise DevOps? So whether you're the CIO or whether you're a mid-level manager, whether you're a first-line manager, whether you're a developer, whether you're a system admin, whether you're in QA, there's always, that question, why mainframe DevOps? Well, there's a lot of benefits to that from everyone's perspective or from the role that they play in the organization. But you can clearly see that we have some bulletized points here. DevOps practice in a mainframe, IBM mainframe environment is critical. Right, and we'll talk about that in a moment. But it spans not only your mainframe on-prem, but it can also span out to the cloud depending on what your model is. Right, there is intrinsic value in terms of quality, speed to market, and other aspects that are inherent to DevOps that you don't typically see at the same pace using, let's say, a legacy or traditional source code management environment. right? And then using newer, modern industry standard tools and also retention and skills. So from my perspective, these are real reasons, in terms of why DevOps on the mainframe. I always like to start off the conversation very simply with this. My question to you is this. Does your organization approach IBM mainframe DevOps as a strategic enterprise initiative? Or is it treated as an isolated technical initiative or effort? And your answer or the answer from your organization the answer that you render is really going to kind of predict to a certain degree, right, your likeliness of success in implementing a DevOps solution in terms of modernizing and going to a CI/CD, modern pipeline, right? One of the critical benefits, and there are many, but first, when you talk about a modern continuous integration, continuous development pipeline, well, speed, right? Rapid prototyping, testing, and iterative releases. That's important in today's environment, all right? And this is really a customer-centric approach that allows the various development teams to validate ideas quickly with their constituents and their stakeholders and to pivot in real time based on feedback. So agility is, that's one of the big benefits, right? And there's going to be cost savings and a whole bunch of other things, and we'll touch base on that. Secondly, from my perspective, automation, you're going to see a lot more automation on the testing, on the deployment, and other aspects than typically what you see today in your traditional legacy development practice. And that's not to say that people have not implemented, enhanced their development pipeline in the traditional model, right, to be as hands-off as possible. But in most cases, the vast majority of customers, that's not the case, right? And then from my perspective, third, aligning mainframe DevOps, right, with agile practices that are probably currently used in your enterprise for distributed applications creates a unified development environment. And that's critical, right, for a lot of different people. Not only the CIO, not only the developer, but everyone that spans in between those 2 points, the QA people, right? Because now they're using the same set of tools across both environments. The admins, right, that are responsible for the environment. So, when you align these things and you have like technologies, things have a tendency of simplifying. Go ahead, Greg.
Oh, next slide, sorry.
No worries, no worries. So I mentioned at a very high level, and I briefly described legacy mainframe SCM, and I kind of started talking about the DevOps and the modern, model. And as you can see, the flow functionally looks the same, right? We have source code storage and the mainframe, PDSs, libraries, if it's traditional. In the distributed world and what we're talking about, bringing that DevOps capability to the mainframe, it's going to be some sort of Git-like repository, right? Some sort of versioning. Your SCM, whatever you're using on the mainframe, it's going to use some sort of tracker, a package ID, or a tag that signifies the importance of the code, right? In Git, we have the equivalent. It's called, a commit, right? Or a Git tag. And then the editor, you're probably accustomed to, if you're a traditional mainframe, it's going to be ISPF most likely. In most cases, it could be something else, right? And then the traditional things that you need in terms of the ability to compile, right, and deploy, right? JCL, and any approvals if there's a workflow involved. As you can see on this slide on the bottom part for DevOps, we have comparable technologies, right, that fit the workflow, and they provide like function, but they do it differently, right? And that difference is really critical in terms of understanding it, because the difference is going to impact your ability to roll back easily, to deploy quickly, right? To redeploy quickly, and to move things, new releases out on a more frequent basis than, let's say, our traditional mainframe schedule. Go ahead, Greg. So you're going to hear a lot about the mainframe DevOps CI/CD pipeline, right? And here's a functional illustration of what it is and what the flow is, right? You have the IDE, and that IDE could be, it could be the IBM, IDZ, it could be Microsoft Visual Code, it could be other products that you're accustomed with and that, that complement the overall, componentry here, if I can say it that way, right? You want to use an intelligent developer's, environment. You don't want to use something that's semi-intelligent. You want something that's going to, so the standard ones, again, are the IDZ as well as Visual Code, and there are others out there as well, right? But the point that I want to make is that it's all of these interdependent components that are going to allow you, all right, to simplify your development effort when properly laid out and implemented, and allow multiple teams to work in parallel, making changes, and your ability to test out and push releases out on a more frequent basis, right? And we'll go to the next slide. And this is going to provide a little bit more details. And what I would say is, you have foundational elements in this IBM DevOps pipeline, right? So this modern DevOps pipeline, again, I mentioned earlier in the previous slide, has several key components that work together, right? You have the you have the IDE, right? Obviously, all right, for the development. And like any modern IDE, right, it's going to allow your developer to check code in, check code out, right? It'll give you syntax highlighting and a whole bunch of other things in addition to real-time debugging, things like that. The Git-based SCM, whichever your organization uses, right, is going to allow you, all right, to have, full version control, branching integration, with DevOps pipelines and things like that. And the cool part about this is we're talking COBOL, we're talking, PL1, assembler, DB2, and MQ series and other languages that are out there that would work within the model that we're talking about. All right. And then the build process, the artifact repository and pipeline. I'm not going to go into details because I want Greg to talk about that as part of his section. Go ahead, Greg.
Okay, unmute. All right, can you hear me?
Okay, so that covers my part. I certainly will entertain any questions or any emails on this. So thank you. Go ahead, Greg.
All right, so now I'm going to try to go into a little bit more into the details about what Joe was describing. So let's start with DevOps. Where do you actually start as a DevOps engineer in the ZOS environment? When running a DevOps implementation on ZOS, we usually start by setting those three core stages: build, package, and deploy. Before we drill down into each one of those stages, here's the general overview. First, the build stage. That's the red one on the left side. We use something that's called IBM dependency-based build, or in short, DBB, and we keep our source code in Git. Next, we also in this stage rely on something that is called ZApp build. It's an open source project that provides scripts that simplify running DBB across different projects. Once the build is successful, we move to the package stage. Over here, we compress the build modules using tar or zip, and we upload them to an external repository, for example, JFrog Artifactory. In this stage, we use another open source project called IBM DBB. It comes from the GitHub, and that project provides scripts which makes this process a little bit easier as well. After that, it's time to deploy. Over here, we use a product called IBM DevOps Deploy, which used to be called Urban Code Deploy, in short UCD, and usually probably I'm going to use that term UCD because that's what I'm used to. And that tool we use to pull the packages from the JFrog and deploy them into the ZOS LPAR. And finally, well, this is a DevOps, right? So we are supposed to automate this whole process. And in order to do so, we use GitLab CI/CD pipelines. The GitLab connects to ZOS over SSH and runs each stage, build, package, and deploy one after another. When we talk about GitLab DevOps, we usually use the term pipeline. Pipeline is basically a defined sequence of steps that move the application from one stage to another. It can be one big pipeline or many smaller ones working together. Pipeline is basically a script or a set of scripts. The pipeline, in order to run, it has to be triggered somehow, right? The most common way to trigger a pipeline is making a change to a code and then pushing this code, those changes, to the Git repository. GitLab will realize that the code has been modified, and if rules apply, it will trigger the pipeline. Another common way to trigger a pipeline is simply using a manual run button in GitLab. So in GitLab, you go to your own project, and if you have a CI/CD pipeline configured, there's a button over there, run pipeline. That's another way to do it. Also, a pipeline can be triggered by an API call or even scheduled. Each project, so application, will have its own pipeline definition. We call it GitLab_CI.yaml. It's basically a file. It's a script which is executed when pipeline is being triggered. Behind the scenes, the script initiates a GitLab runner, which is kind of like a virtual operator. The GitLab runner executes commands we scripted on the remote environment, so ZOS, USS, or Linux. Here is the most basic GitLab CI YAML file definition. It defines the stages, right? Build, package, and deploy, and then sets up scripts that will run on the destination for each of those stages. These scripts are basically bash commands that run on the mainframe, so USS, right? For the build stage, we tell it to run DBB via zapp build groovy script and compile the programs listed in list.txt file. So this is just an example. This is a very basic one, right? We basically just want to compile a list of programs listed inside of the list.txt file. Here's continuation of the same script, but this time we have two different stages. The packaging, right? We call, again, another script, which comes also with the IBM DBB repository. And it basically takes the binaries that have been built in the last successful build, so in the previous stage, right? Zip them up and ships them to the external repository, in our case, JFrog Artifactory. And then it also notifies the IBM UCD or DevOps that the new binary is available. The last stage, deploy, executes one more script that came from the IBM DBB repository. And then it initiates an actual deployment using a remote call to IBM DevOps UCD. The goal is to have a fully automated pipeline, right? CI/CD, continuous integration and continuous deployment. Integration means that, when we make a change, we want those changes to be automatically integrated, right? And then we also want them to be automatically deployed. So CI/CD. That process, that pipeline runs through each stage whenever a build is triggered. It builds the code, it packages it, it stores it in a repository, and then tells UCD IBM DevOps to start the deployment. All right, as the pipeline grows, right, because what I just shown you is just a very, very basic example, but you will be adding features, you will be adding rules. I mean, the pipeline itself is going to become a big program. Things can get complicated. Every project needs its own pipeline, right? And at some point, it can be very overwhelming. You make changes in one place, in one project, pipeline, and then you forget it, to implement those changes in another one. It becomes a mess. So instead of having a full pipeline inside of every project, meaning every application, right, we can have one dedicated project just to host the master pipeline. So universal master pipeline, and then have all the other projects, for example, my project 1 and my project 2 simply include the shared pipeline into their definitions, right? So this way, when you need to make changes, you'd make those changes in just one place, much simpler. Here's an example of a project's GitLab CI YAML files. On the left side, that's the projects, the applications, right? Unique definition. And you can see that it has only some basic settings. And then instead of defining the whole script, all the stages, and everything, it simply just includes, I don't know if you can see my mouse, probably not, at the very bottom, it just simply includes the master pipeline, which is shown on the right side of the screen. The master pipeline could be also just a huge script, but often it's easier just to split it into smaller ones and then combine them, again, using include functions. So basically, we have projects pipeline, including shared pipeline, and the shared pipeline is including, again, smaller pipelines. Of course, not all projects are the same, right? For example, we might want to deploy one project into one LPAR and some other project into a different LPAR. We might want to use different settings, right? So we need a way to tailor the pipeline for each project. This is what variables are for, right? Each project's GitLab CI YAML file, yes, it does include the pipeline, right? The master pipeline at the end. But before the include, we can override whatever variables we need. Variables basically become configuration settings, which we can set for each project application individually. Here's a fragment of a shared master pipeline, which is controlled with variables, right? Which may be set in a parent, so application's unique GitLab CI file. So instead of hard coding values, we use variables. For example, I set a variable called UCD_env. That's the variable I'm using to tell UCD into which environment I want a specific module to be deployed into. If variables are properly formatted with descriptions and default values, they may turn into basically options which users get to choose if they decide to do a manual pipeline run from the GitLab UI. So if you have a project and all the variables and all the pipelines are defined correctly, you click on the manual run, you may end up with a screen like this. Basically a wizard, right? User can specify what they want to do, what type of a build they want to make. Do they want to deploy, or they maybe just want to package it? A manual pipeline run. So it is still automated, right? But user get to choose in a much easier way. And I gotta tell you, people love this, right? Because before hard coding all the values into their specific pipelines, they can test it first using wizard like this, and then when they're ready, they hard coded it and they schedule it. All right, in ZOS, programs often have dependencies, right? And if you want to build a program properly, you need to have those dependencies available. DBB keeps track of those dependencies and makes sure that they're available during the build process. It also supports something that's called incremental builds, where only programs that have changed since the last build are compiled. DBB stores all this information in a DBB metadata store, which can be hosted in DB2, which is the recommended way, or it can be stored in a file system, which is really just for testing purposes. DBB supports few types of builds. For example, build a list of programs. I already mentioned this before, but here's what it is. In this scenario, the build scope is defined through a text file, right? Which lists files to be built. The files are scanned, modules built, and dependency metadata and build results are stored in a DBB metadata store. Oh, here's the actual command that you would use in order to make a build list. So at the very end of the command line, you specify a file which contains a list of the programs that you want to build. Another one, impact build. That type of a build is very useful. It builds only programs affected by your last change to the source files, right? So instead of building the whole thing, only what has changed is being built, impact build. The merge build is very similar to impact build, but instead of comparing it to the previous build from the same branch, it compares it to the main branch and builds it as if it's already merged into the main branch. So slightly different scenario, but also very useful. There are a couple of more build types. A full build, for example, which builds everything within the project, right? So you'll have, if you have hundreds and hundreds of COBOL files, they're all gonna get built. Another type of a build, a user build. This is probably the most simple ones because in this build, user build, you specify a single file, literally just a single file that you want to build, enter, and it goes. Here's an example of a build stage. So this is back to the pipeline itself. In a nutshell, we just call a Groovy script, specify what type of a build we want to make, specify if this is a list build, for example, we specify a list name. In this case, this is a variable, right? Because I want to be able to control the variables, from my parent pipeline. And yep, that's how it looks. Here's the package stage, so the middle one, right? At this stage, GitLab runs a script called dbb ucd packaging groovy, which comes from the IBM dbb repository. The script does two things. First, it uploads the compressed package to the Artifactory and then creates a component version entry in IBM DevOps deploy, so UCD, with all the metadata information about the build, including the URL pointing to the package in the Artifactory. And this is how you call it. Here you can see how it looks inside of the DevOps deploy after a new build has been successfully created. A new component version shows up, right, with a timestamp and includes all the metadata, including external repo URL where the package can be found, list of the modules that have been compiled, and all the other necessary information required for deploying a package. The last stage, that's how you call it, that's how you execute it, it's the deploy. At this stage, GitLab runs another IBM DBB script called UCD deploy groovy. This script makes an API call to UCD, IBM DevOps, asking it to run a predefined process, for example, deploy. Then inside of the UCD, you would have configured environments and the deploy process itself, which, for example, pushes the new code to PDS and performs a new copy in CICS. And that happens with the help of UCD agent. UCD agent is a component of IBM DevOps, and it runs inside of the ZOS. Basically, it acts like a client which checks in with IBM DevOps, and whenever there is a new work to run on the LPAR, like deploying a new module, for example, it takes care of it. One more thing about GitLab Runner and USS, right? When a GitLab Runner executes a job, it will clone or pull the source repository that it needs to work with, right? And we'll save it somewhere inside of the USS. And if you want to be able to run multiple builds at the same time, you will have to have multiple GitLab runners. Each runner will operate in its own isolated environment, basically a folder, making sure that they do not step onto each other. Remember, this is Git, right? So after the pulling, if you would be doing this manually, you would pull the repository, right? And then you would check out a specific branch. And that is exactly what GitLab Runner does as well, right? After pulling the repository, the GitLab Runner checks out the specific branch the pipeline is supposed to, to be built with. And then the next time job runs on the same runner, it will just compare the commits and pull only whatever have changed. All right, that was it from me. I will give microphone back to Joe. Hopefully, Joe, you're still with us. You're on mute. Joe.
Did we lose Joe? Ah, he's muted.
Can you unmute? Maybe he cannot find the button. Can you try to unmute him?
I can't personally do it. All I could do was ask him to unmute.
I'm sorry, Greg, were you trying to reach out to me?
Oh, yes, it's your turn.
Oh, very good, very good. Thank you. I apologize. And Greg, I learned a lot. I learned a lot on this session as well, so thank you. Wow. All right. So, Greg, thank you for going into a deeper dive. What I would say, things really to consider in terms of when you're developing your pipeline or when you're architecting it, because it's not something that just manifests itself automatically, right? It really, in the organizations that we've been working in, and we're actually doing, the modernization of their DevOps on the mainframe, these organizations already have practices built in their distributed environment that really, are DevOps, period. Right, so they in the organizations itself, there's a lot of in-house expertise. Unfortunately, in one respect, right, that all that knowledge is on distributed platforms and distributed applications. Right. However, the benefit is some of the other supporting areas like the QA groups and some of the other teams, admin teams, using these common tools across both environments, Z as well as non-Z platforms, that certainly does improve the situation. But there was a point that I wanted to make. Greg has mentioned the architecting of the pipeline and some of the complexities and some of the things that can be done from a design perspective to simplify it and to make that pipeline as universal as possible, requiring little or no changes as possible. It's not to say that, it's void of changes, right? There are probably periodic enhancements that have to be made to the pipeline, right? But to have one universal pipeline versus many point specific or point solution pipelines, there's benefits to having one versus many. And I just wanted to emphasize that because the way that Greg has described the pipeline and the design, it's parameter based, it's reusable, and it gives a lot of flexibility and extensibility. All right, so planning for a new CI/CD. Well, look, this in and of itself could be a 4-hour or 40-hour conversation, but a lot of things have to be taken into account. And what I would say is, right, there are 3 phases. Typically, there's a planning, there's a proof of concept, and then there's the final assessment in terms of the outcome of that proof of concept and everything that needed to be put in place. But there are a lot of considerations that have to be taken into account. All right. When you plan for this new environment, the complexity of your environment, whether you're small, medium, or large, and what I describe as small is someone, a client that has maybe 50,000 artifacts or copybooks, source modules, and things like that represent the application versus someone that has 100,000 versus someone that has 500,000, right? Because, size does matter in this sense, right? There's a lot of code, right, that you need to be aware of in terms of code that's current, that's being updated on a let's say a regular basis versus code that hasn't been touched over the last 10 years. So there's considerations that have to be taken into account, whether or not that code that has been touched in the last 10 years, whether or not it'll actually compile using the latest version of the compilers you're using, or if it's dependent on an older version of the compiler. So there's a lot of planning that has to come into account. So what I would say is, like anything, you need a thorough assessment of your existing environment, and we certainly Converge does that, and it helps us and you to understand, potential bottlenecks and some of the things that could inhibit you in terms of going from where you're at today, legacy, into your new state, modern, right? And scoping all of that out and really setting really clear expectations. Greg, you can go to the next slide. Greg can talk to these issues better than I can. I mean, I was with him, side by side when we were running into a lot of these problems, but taking something that's EBCDIC and moving it on to ASCII, and some things do not translate correctly. And also taking something from EBCDIC and putting it in UTF to make it more universal, there are considerations that have to be taken into account with that as well.
So
Right.
just a quick note on this. So when you store your code inside of the GitLab, inside of the Git repository, so basically outside of the mainframe, then of course it will be stored in the UTF, right? So you can actually go over there and edit it using it, non-mainframe tools, right? But when the code is being shipped to using the Git, basically command to the mainframe, GitLab runner handles that. In the background is actually changing the code page. It's changing it from the UTF back to the EBCDIC, right? And now Joe's probably going to mention this, that if you have, non-writable characters, that could be an issue. But, there are ways to go around that. All right, please go ahead, Joe.
Well, thank you. Thank you for that clarification. So what I would say is, these are important considerations, and these are the type of challenges that you run into, right? And this is just a small subset, right? But what I would say is, from our perspective, the way that we try to mitigate this is we propose a pilot, a small pilot proof of concept, and we really try to target an application with the client and development team that kind of is representative of their entire application base or close to it, right? And we go through the process of building out the environment, right? And architecting the pipeline and developing it and putting it in place, and then actually taking these POC developers and other members of the team and putting them through the workflow and the pipeline and seeing how it's done in the new world, right? So that POC is really critical, and that helps demonstrate capability, and it also helps to establish confidence. And then, once that pilot is successful, then we focus on, and Greg, you can go to the next one. Once that pilot is successful, we're able to then sit down and review, any barriers that we encountered, any challenges, and how we remediated them, and then map out a more comprehensive roadmap, all right, to migrate the remaining part of their application base, right, into the new environment, and then transition them. So we do that, and we do it. We've done that successfully. So that really, what's the next slide, Greg, if you don't mind? Okay, that concludes our session. And if there are any questions, Anna, please, we will gladly answer them.
So here, just some URLs over here. Those are the links that all sorts of documentation, samples, videos that we've been using, when we were learning this stuff, when we were doing this. So those are very, very useful links.
And is there a link? What's the next slide? Oh, perfect. Go ahead, Greg. So I'm sorry, can we go back to the previous slide? So what I want to thank everyone, especially Anna and the GS UK group, for allowing us to present today. What I'd like to do is also point out in the contact slide, we have a white paper that has been published. I think if you download that, I think you'll find it very informative. Yeah, I think we're good, Greg.
Yep, that's it.
Okay, so thank you, Greg, and thank you, Joe, for all the information. Please do fill in your feedbacks as well. Everybody, that's a given for all sessions. If anybody wants to ask any questions, have a discussion on this topic, you are now able to unmute yourself in order to speak. During the presentation, we did have a question or a comment in the chat. Unfortunately, Charles, who put it in there, had to drop before the end. So as it was a comment about the beginning, and it's not my topic, I can't say if it was valid or not, but I think everybody saw it because it was to everyone. So
is this from Charles?
it was from Charles, yes, but as I say, he's gone.
Right, but he brings up a very interesting point, because there is a slide where we compare both legacy SCM and the new DevOps, and granted, you will see some similarities. All right, but similarities in functionality and derived functionality, right, I think is really the difference. And this is what I mean. And again, some companies have done remarkable things with their legacy SCM and just their development practice, right? But it's really rooted in what we'll call legacy technology. But they're able to automate, they're able to do a lot of things. But when we ask them, well, are you challenged when it comes to parallel development? No, because we develop in two different applications simultaneously. Okay, great. But if you start coming down to a lower level where you're now in the same module, can you do parallel or co-development? And the answer typically is no, right? So that's a constraint point. And in large organizations with large number of development teams and all of that, that could present a real problem. So I think Charles's point is valid, looking at it and understanding where it's coming from. It looks like, they've been doing this for some time, but there are other attributes or considerations that have to be brought into the conversation to see really what the benefits are.
Yeah, if you'd like to paraphrase Charles's question, because I'm not sure it will be on the recording, that would be fine.
I'd like that. So from Charles, what do you think that traditional legacy source code management looks like? The software configuration management practices we have in place for the last 25 years looks remarkably like what you are calling the DevOps approach. And I would agree with that statement. But again, functionally and what you're deriving functionally, I think that's the differentiator, the agility, the ability to continuously, to integrate and deploy, and things like that. Somehow not somehow, I know that DevOps, no matter what you've architected in the, what I'll call the legacy world, if properly architected, that's great. But in the DevOps world, it's, it may look the same in certain and have a similar feel, but the functionality that you're deriving, it's going to be different and hopefully better. It should be significantly better. Time to market, reusability, just productivity, the whole 9 yards.
Thank you. Anyone else have any comments on this particular topic? As I said, you can unmute yourself, or if you don't like to speak out loud, you can put it in the chat. Okay, so seeing no movement on the mutes, nothing in the chat, just remains for me to say thank you to both Greg or Gregory. I never checked if Greg was okay, and Joe or Joseph, for the session. And I hope everyone enjoyed it and learned something, and we'll hopefully we'll see you back here tomorrow. And thank you, Rod, for
Thank you
that.
very much.
Thanks.
It was a pleasure to represent to
Anna,
you.
thank you. Thank you, everyone. Thank you, Greg.
Okay. Thank you very much then, guys. Last session of the day.
Ready? Bye-bye.
Bye now.